Hello guys, this is a question for you. You can try this for yourself and have a look at it. I will give you 5 seconds and after 5 seconds I will try to describe this question to you. So I'll wait, pause the video, try it yourself for 1, 2, 3, 4 and 5. Now in this question, uh, it's saying that a tennis ball is being moved from O to A under the influence of gravity. So, first of all, we should know that in a rolling motion, work done by friction is always equal to zero because the contact surface and the point of contact with the body, they are at zero relative speed. That's why the point of contact is not moving under influence of friction. That's why the work done by friction is zero at that point. Hence, we can say that we can apply the conservation of mechanical energy on this particular scenario. We can say that the ball is actually moving downwards by a distance of 1.8 meter. Here I can say, okay, it's moving down with at a height of 1.8 meters, so it will lose its gravitational potential energy by m times g times 1.8. Now all that energy which this ball lost, it will go into the kinetic energy, but this kinetic energy will be consisted of two portions. One is rotational kinetic energy, another is translational kinetic energy. So it will be equal to I omega square by 2 plus mv square by 2. Okay, now because the moment of inertia I for this ball about its diameter is given as 2 by 3 mr square, and because the ball is purely rolling, which means v equals to omega r, hence omega equals to v by r. Now we can put the values of I and omega from here and here in this equation. So it is I 2 by 3 mr square instead of omega square v square by r square into 1 by 2 plus half of mv square. So all the m's, all the r's have been cancelled. We get velocity equals to velocity square equals to g times 1.8 multiplied by 2 6 divided by 5. Now this is v square. We have to find out what is the value of range with which this projectile will fall. Okay, now we can see that this ball will having any kind of torque because while in motion under the influence of gravity only mg is acting downwards, so mg cannot announce any kind of torque on this body with respect to the center. That means whatever omega, whatever angular speed it has contained, it will not change, which means only center of mass speed, which is v, will influence the range, which means range will be equal to v square sine 2 times angle 30 degree divided by g. Putting the values, we will say g times 1.8 times 6 by 5 sine of 60 degrees, which is root 3 by 2 into 1 by g. So g got cancelled out. Putting all the values in perspective, we can say AB, which is equal to range, is equal to approximately 1.87 meter, which will make A option as the correct one. Thank you guys. Hope to see you again.